In mathematics, the function f of x simply takes the input, then processes the input, then produces exactly one output for each input. We can easily relate this function with lots of examples from our day-to-day life. One such example is a food blender. Here, the input to the blender is strawberry and the output is the strawberry puree. The output varies according to our input. If our input is an apple, our output will be an apple puree. Let's consider a function sin x. If our input is 0, our output is also 0. If our input is pi by 2, our output is 1. For pi, it is 0. For 3 pi by 2, it's minus 1. And for 2 pi, it is 0. Now, if we plot a graph with input in x-axis and output in y-axis, we'll get a sine wave. So, finding the graph, or in other words, a waveform from a function is not a big deal. But what if we need to find a function from a waveform? If you are interested, continue watching. Hi, this is Benila. I make videos based on engineering concepts. If you are into this, consider subscribing. In this video, we are going to see about the mathematical function of different waveforms. The commonly used waveform have either linear function or sine function. So first, let's learn about this linear function. Let's assume that you are reading a novel for about 20 minutes. The number of pages you read increases with time. If you plot the graph with time in x-axis and number of pages you read in y-axis, then you will get a straight line. The straight line has a linear function. The general equation of a straight line or a linear function is y or f of x is equal to mx plus c. When x is 0, this equation becomes y is equal to c. Therefore, c is called the y-intercept. This means c is the value where the graph crosses y-axis. For example, in this graph, c is 2. Here c is 4 and here c is minus 2. Now let's see about this m. This m is called the slope of the line. To know the real meaning of the slope, let's consider the graph of two readers, reader 1 and reader 2. What difference do you find in the reading pattern of these two readers? Of course, reader 2 reads faster than the reader 1 because reader 2's graph is steeper than the reader 1's graph. The word steep is related to the slope. The slope at any point in a straight line is same. The slope can be calculated as a change in y divided by change in x. If we consider this point as x1, y1 and this point as x2, y2, then the slope m is equal to y2 minus y1 divided by x2 minus x1. Now, let's consider another reader, reader 3. He found the book to be so boring that he was stuck at the very first page for 20 minutes. In this case, the change in y is 0, therefore the slope is 0. Now let's consider this example. Here there is a linear function in the interval 0 to 2. The coordinate point of this point is 2, 2 and this point is 0, 0. The slope m is equal to y2 minus y1 divided by x2 minus x1. If we apply the coordinate points in our formula and then we'll get the slope m as 1. Here the y-intercept c is 0. Therefore f of x is equal to x for the interval 0 to 2. Similarly, let's consider another example. Here also there is a linear function between the interval 0 to 2. Therefore, let's find the coordinate points. The coordinate point at this point is 0, 2 and this point is 2, 0. Therefore, the slope is minus 1 and y-intercept of this graph is 2. Therefore, f of x is equal to minus x plus 2 for an interval 0 to 2. In this example, the slope m is 0 since there is no change in y and y-intercept c is 2. Therefore, f of x is equal to 2 for the interval 0 to 2. We all know that this function is sin omega t. Since the maximum current is mentioned as Im, our function f of omega t is Im sin omega t. Similarly, in this example, this waveform looks like a sine wave. Therefore, let's compare this wave with a sine wave. It's obvious that this given waveform is the negative of the sine waveform. Therefore, f of omega t is equal to minus Im sin omega t. Now let's see this example. When we compare sine wave with this given waveform, we can see that during the interval 0 to pi, our sine wave matches with the given waveform. But from pi to 2 pi, it becomes the negative of the sine wave. Therefore, f of omega t is equal to Im sin omega t for the interval 0 to pi and f of omega t is equal to minus Im sin omega t for the interval pi to 2 pi. Similarly, let's consider this example. Here, our sine wave matches with the given waveform from 0 to 3 pi by 2, but after that its value becomes 0. Therefore, f of omega t is equal to Im sin omega t for the interval 0 to 3 pi by 2 and f of omega t is equal to 0 for the interval 3 pi by 2 to 2 pi. The, the function f of x plays a major role in the calculation of average and RMS values, which will be discussed in our next video. If you are interested in this, don't forget to subscribe and click the bell icon so that you will be notified each time I upload a video.